In this video, we're going to answer these problems that have to do with charge, electric potential difference, and electric energy. Before we actually answer the questions, let's go up here to our summary table of what these different things are. So first of all, we have electrical energy, and we know that's just the energy involved with electricity, right? So we know that's measured in joules. Secondly, we have charge, and charge is basically just a group of positive or negative particles, and we measure charge in coulombs, and a coulomb is just 6.242 times 10 to the power of 18 electrons. So it's just basically a bunch of electrons, and that many specifically. Lastly, we have electric potential difference, and that's sort of like the push that those electrons get. We can calculate electric potential, which is measured in volts, by the way, as the energy in joules over the number of coulombs, the charge. So using this information, let's go down to these questions and see if we can solve them. Question number 1. If there's a charge of 1 billion electrons on a balloon after rubbing it against your hair, how many coulombs would that be? So you can picture that, right? Rubbing a balloon against your hair, it's gonna basically pick up some electrons or deposit some electrons, and that gives it a charge. So if we have 1 billion electrons, how many coulombs do we have? So remember, 1 coulomb is equal to, what was it again? I have to go back up here, 6.242 times 10 to the 18. 6.242 times 10 to the 18 electrons. Now, in this question, we only have 1 billion electrons. And 1 billion is like saying 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. So you see, this number, 10 to the 9, is actually a lot less than this number, 10 to the 18. So we're going to have less than one coulomb. Now, how do we calculate that? Well, we can think about it this way. If we have, this is basically how many electrons we have, and this over here, this number, is like the number of electrons per coulomb, right? There's 6.242 times 10 to the 18 electrons per coulomb. So in order to solve this, I'm actually going to think of a bit of an analogy first. I'm going to give you an analogy. We all know a dozen is 12, right? So say I had 6 buns that I'm going to buy from the grocery store. How many dozens of buns is 6? Well, we know a dozen is 12, right? So, and we know 6 is half of a dozen, right? So we can say like this, 6 over 12 buns, because there's 12 buns per dozen, right? What's going to happen here is the buns are going to cancel out. That dozen, since it's down here in the denominator, it's going to go up to the top. So we end up getting 0.5 dozen. That's how we would find 6 buns out of a dozen. So it's the same thing with the electrons. Basically, we can think of like the dozen as our coulomb, our definition of a coulomb. So we're going to have 10 to the 9 electrons over 6.242 times 10 to the 18 electrons per coulomb. And what's going to happen, these electrons are going to cancel out, the coulomb's going to go up to the top, and if we do that, we get the answer of 1.60, if we round to 2 decimal places, times 10 to the negative 10 coulombs. So what does this mean? It basically means we have a really small number because it's 1.6 with the decimal moved over 10 times to the left, right? It's a really small number. So we don't have a coulomb, we actually have a lot less than a coulomb. So even 1 billion electrons is a lot less than 1 coulomb. A coulomb is many, many, many more times. Okay, that's question 1. You'll notice the answers also are up in the top right, so you can check as you go. Second question, find the potential difference between 2 points if 10 kilojoules is required to move 2.5 coulombs of charge between those 2 points. So basically it's saying we have a certain number of energy that's going to be pushing on these electrons to move, right? What's the electric potential difference between these 2 points? Basically, what kind of battery do we need to apply this amount of energy to the charge? So whenever we have potential difference, we have energy and we have charge, we actually have an equation that relates those two things. If we go back up here, V equals E over Q, right? That's our voltage, is the energy over the charge, right? And we should always, before we just plug stuff into the equation, we can just try to plug in 10 and 2.5. But look carefully here. What units do we have for the energy? Kilojoules. What do you think we want for this? We want joules. So before we actually just plug stuff in, I'm going to write down what we have given in this question. We have the energy not as 10 kilojoules, but if we turn that into joules, what would that be? Remember, a kilojoule means 1,000 joules. So it's like 10,000 joules, right? 10 kilojoules would be just 10,000 joules. And we also know Q, or our charge, is 2.5 coulombs. So we know these things. Now we can just plug them into the equation to find our electric potential difference. So that's just going to be 10,000 joules over 2.5 coulombs, which gives us, if I do it on my calculator, 10,000 divided by 2.5 gives me 4,000. And remember, a joule per coulomb, if we divide those two units, is what a volt is defined as, right? So 4,000 volts. We need a lot of volts to apply that energy to that amount of charge. And if we check our answer up here, 4,000 volts, that seems to agree. Moving on to the next question. Calculate the energy transformed in a 15-volt adapter that has 75 MC of electrons flowing through it. So first of all, we know we have energy here. We know we have electric potential. We know we have coulombs. Well, do we have coulombs? What does this MC actually mean? What do you think it means? Well, think about millimeters or milliliters. What does the milli mean? Milli basically means 1,000th, right? So basically what we're going to have is we have 1,000 millicoulombs equals 1 coulomb, just like 1,000 millimeters in 1 meter, right? So again, similar to the previous question, we're going to want to convert these all to sort of the base units. So we're going to want to convert that to coulombs. So I'm going to write down given again, just so we can list what we're given in the question. We're given that 15 volts is the electric potential, right? So our voltage is just 15 volts. We know that. And the 75 millicoulombs is charge, right? Or Q. Now let's convert that to coulombs. So remember, millicoulombs are a lot smaller. So when we convert it to coulombs, it's going to be a much smaller number, right? We're going to divide by 1,000. Because to go from millicoulombs to coulombs, we would have to divide by 1,000, right? To get 1,000 to 1, we'd have to divide. So we're going to get 0.075 coulombs for that, right? Now, what we can do is we can just write out our formula that we know, V equals E over Q, the formula that relates those two things. And now in this case, we're trying to solve for what? We are trying to solve for the energy, correct? So in order to solve for the energy for E, we can rearrange this equation. Let's do that before plugging stuff in. So I'm actually going to cross multiply that V and that Q, right? So E is just going to equal V times Q. We know what V and Q are. It's in our question. V is 15 volts times 0.075 coulombs. And if we multiply these two things, it's going to come out, remember we're dealing with energy here, so what unit do you think it's going to come out as? If you said joules, you are correct. As long as we're working with the base units of volts and coulombs and joules, always the answer is going to come out as one of those. So if we do that multiplication, we're going to get 1.125, which I'm just going to round to 3 significant digits, 1.13 joules. Okay? You notice the answer here is just 1.1 joules. They round to two significant figures, but I did 3. There you go. So that's the answer. So basically, that's the amount of energy that would be pushing those 75 millicoulombs through that conductor. So what I want you to do now, I'm not going to actually answer these last 2 questions with you. I'm going to stop here. I want you to try those 2 yourself. Okay? So we're going to end the video here. Try those yourself. The answers are on the page. And if you have questions, find me tomorrow and you can ask. All right?